Hey kids, welcome to my kitchen, or really not my kitchen, but another friend's kitchen that I'm lucky enough to use and probably will never be invited back again. We are going to be doing all sorts of super cool science. I'm in this kitchen, you're in your kitchen, or hopefully some random friend's kitchen that you have. We're going to do all sorts of science with ingredients you already have around. We've got cornstarch, we've got some soap, we've got borax, all sorts of neat stuff. We're going to be doing science experiments right here together. Also, we're going to be going back and forth and seeing a live show. I'm so sorry I can't be there with you to give you a real live show, but I will be back maybe in the fall or next year, and we're going to do all sorts of really cool stuff. In the meantime, we're going to see some outside big show experiments that I can't do here, and some kitchen experiments that you can do at home with a parent or an adult or someone with a lab coat. So join me for some super cool science. Here we go. I've got to get my stuff. This is not my house, so I don't care. Okay, safety warning. What do you never play with? Fire. Who has seen a movie with a dragon? Only a few people. What do dragons do? They breathe fire. Okay, this is a cool movie effect. If you're making a movie with a dragon, but you don't have a real dragon on your movie set, use this stuff. It's called dragon's breath. Ah! That's really warm. Okay. Ah! Okay. Another great experiment we shouldn't try at home. This is, everybody say dragon's breath. This is like a podium or dragon's breath. Now, it's a little, here, I'll show you. Nothing in my hand right now. Can you guys see that yellow powder from where you are? Yeah. Now, here's your quiz. Theoretically, what would happen if I took this lighter? What's going to happen? This is where someone says, stop, don't do it. Oh, we're crying out loud. Somebody say, stop, don't do it. Okay, I'm going to do it anyway. But yeah, I appreciate you caring about me. Well, what would happen if I did it? It's going to burn my hand off. Is this a good idea? No. Thank you for telling me to stop then, people who care about me. Okay, here we go anyway. 3, 2, 1, and... What happened? Nothing happened. It didn't burn my hand off. How come it's not working? Who knows the answer? Say it if you know. You don't know? You need 3 things for fire. You need fuel, this stuff. You need heat, this stuff. And you need... Everybody say oxygen. Take a deep breath. Let it out. What do you breathe in? You breathe in oxygen. We need oxygen to live, and so does fire. So if you just do this, no oxygen can get to it. But if you just add oxygen, then it works just great. Okay, the first thing we're going to do is make a polymer. Everybody say polymer. Thank you, disembodied heads in my studio audience, which may or may not exist as far as you know. You can play along at home by saying polymer. A polymer is a bunch of molecules that are linked together in a chain like a web. We are going to make one right now so you can see what I mean. Now, we have our first ingredient, which is, everybody say borax. Borax is kind of weird soap type thing. It's in your laundry room. No one really knows what it does. It does a bunch of things, including this. My next ingredient is, say water. Water, okay. So, by the way, in chemistry, generally, you measure your ingredients. Today, we're not doing that. We're just going to dump stuff in. It's going to be nice and fun. And you might have some mixing utensils. We've got mixing utensils right here. This is hands-on science. I want you to enjoy every bit of this by getting your hands in there. Let's see. Dump some water in there. Dump some borax in here. Now, what you want, you mix this, is going to be a sodium borate solution. Now, a solution just means we're just going to mix it until it stops dissolving inside the water. So I can feel it. Normally, it would be clear, but it's a little bit grainy because it just kind of dumps way too much stuff in there. Now, that's our first part of it. Got our borax solution there. Our next ingredient is, everybody say glue. Yeah, so we've got Elmer's glue. Any white glue, any kind of school glue works for this. So, once again, we're not going to measure, just going to dump stuff in. And, that's probably perfect. Who knows? Now, take your measuring utensil, go in there. Now, squeeze it underwater. You want to squeeze it underneath. Oh, yeah. Now, what you can see, well, you can't see, but you can feel it, it's turning into a polymer. All those molecules are linked together. Now, I'm squeezing it underneath the water surface, because if I took it out and squeezed it, it would explode and get all over this nice kitchen that I don't own. So, we're going to keep on squeezing it. Now, what I made is, let's see. This is silly putty. Or it will be silly putty. Once let me squeeze it some more in there. Now, if it's still a little liquidy, still a little ooky, that means you just need to squeeze it some more. Otherwise, it might have a slime-like consistency. Some people call it oobleck, but it really is the color or the consistency of silly putty. And get back here. Okay, so now I've been squeezing this, and I squeeze this into this ball-type shape thing, and it's kind of like a rubber ball. So let's see if it does it. Ah! It even bounces. Ah! Come back here. Ah! And it bounces across the house. A great game to play at home, kids. Okay, yes. So what we did, we just created a polymer, and it flew off somewhere. Ball. Ah! Yeah, and it magically comes back to you. That's how cool this is. We just created a polymer. All the molecules are together, and you can make silly putty. Try putting this on a comic strip or a newspaper, or just make it into a ball, or just squeeze it if you ever get stressed. Just like I am right now. Perfect stay-at-home science. In your freezer, you have ice. If you have a cup of ice, and you leave it on your kitchen counter, what happens to it? It melts into water because it's wet. Now, hold that thought again. Except this ice is not wet. It is the opposite of wet. It is? Everybody say dry ice. Who has seen dry ice before? If everybody, good. Then what should I be doing if you know this much? Wearing gloves, yes. Why? Yeah, it can hurt. If it'll burn my hands. That's why I'm using safety gloves. It's not just cold, it's really cold. It's negative 109 degrees. It's so cold, if I touch it, it'll burn my hand. It's like sticking your hand in a 300-degree oven. So it's really cold. It's kept in this cooler. This is dry ice, which is made of the stuff you breathe out, which is carbon dioxide. Now, it's really cold, negative 109 degrees, and, yes. This is dry ice. It's melting. Is it turning into a liquid? No, it's turning into a gas. Everybody say sublimate. Sublimate, it's a cool science word. It means something's melting and going from a solid, not to a liquid like water, but to a, say gas. Yeah, it's turning into gas. So put that away because it's really cold. Now, who has seen a movie where you have a scientist or wizard, they're making all sorts of groovy potions? This is how they do that movie effect. We need, everybody say flask. This is my sidearm. See this arm coming out of the side? My sidearm flask. And this needs to go inside there, and it's not going to fit, so I need my special science tool, which is, yes, in science we use specialized measuring tools like the hammer. Okay, beautiful. You know what? I need a volunteer. Are you feeling brave? Come here. Nah. You look thirsty. Are you thirsty? Say, yes, I'm totally thirsty. Good, I believe you. Okay, good, because guess what you're going to do? You're going to drink my yummy, delicious potion. It tastes just like candy. You'll love it. And, it's tasty when it turns a nice, groovy blue color. And it's delicious. It tastes just like candy. So, open your mouth, stick out your tongue, and drink. Is it delicious? Drink it. Do you recognize the taste? Oh, wait, actually, we'll have people come up here. Anyone else want to drink it? Come on up. Get up here, get up here, get up here. Now, this is carbon dioxide, the same stuff that's in a carbonated soda. So some people taste get up here. Get over, have to pass this line. Get all the way up here, pass the line. Some people taste a Sprite or a Slice or a 7-Up. Does it taste just like candy? Or was I totally lying about that part? No. Yeah, no, it's disgusting. It's gross. Here, drink some more. You know when you drink a soda really fast and you have to burp? That's what this is, like drinking a burp. Here, drink a burp. Isn't that yummy? No, it's awful. Yeah, which is why I'm not doing it. So in our last segment, we created a polymer, and now we're going to, everybody say, destroy. Thank you, very verbal tech crew. You're doing great. Okay, so we're going to just destroy a polymer. The first thing we have is what is it, kids? It's a cup. We have a styrofoam cup. Now, what we're going to do, and then I need my acid, which is, everybody say acetone. Acetone is, you'll recognize the smell. It's that stuff in fingernail polish remover. Gross. So here's what we're going to do. We're going to hold one and put a little bit of the acetone on it. Hold the other side. Sorry about whoever's counter this is. You might want to put something on your counter when you're doing this at home. And then you pull and spread it apart. What's happening? You can totally see it disintegrating. It's breaking apart. It's the polymer that's locked in like this, breaking apart into this weird spiderwebby thing. And it's totally groovy. Let's see. And you can do this. So find all the styrofoam cups in your house, and you can do this with them. It's a lot of fun. That's lovely. Now, it's not limited to cups. Whatever you have in styrofoam. You guys have seen these before. Packing peanuts. Right now, they're on the inside of a glass. Usually, they're on an outside of the glass for packing. But we've got some styrofoam peanuts in there. And when I get them and you get them, we just throw them away in the trash can, and they fill up all the landfills. The only way to get rid of them, acetone. Oh, isn't that lovely? And who's thirsty? Wait, is this a good idea? Probably not. Oh well. What will probably happen? Ah! Ah! Okay, mop! Ah! So you might want to put something on the bottom of your counter like this so it doesn't get acid all over your friend's granite countertop. Okay, which brings me to my beautiful girlfriend Sheila. We're going to do the same thing with her, which is, remember this stuff? Acetone. Isn't she beautiful? Well, I think she's gorgeous, but everybody say makeover. Yes, we're going to give Sheila a makeover, basically the same thing. And like you've seen before, you can destroy a bunch of foam stuff you have lying around. You might have cups, you might have plates, you might have just a random countertop, or you might have my girlfriend Sheila. Let's just fix her eyes, make her even more beautiful than she is. Yes! Isn't she lovely? Let's fix her lips. Yes. Nice. Everybody say nose job. Nose job. Oh, that's just perfect. Give her a little bit in the ears there. And isn't she nice and lovely? You can, wow, perfect. Yes, just like prom all over again. So you can have things like this, fun science. And you know what? Leave this and come back in about 20 minutes. You can touch it. It's really soft and really groovy. Not right now because it's kind of, you might not want to touch it right now. But come back at the end of the show and touch your foam head, and it's really groovy.